When rounding off a number, either rounding up, rounding down, or truncating a number, our main goal, basically on doing that, is to make the number simpler or shorter, and at the same time, keeping the value as close as possible to the original number. In this video, I will show you the rules, especially on identifying which and which is not a significant digit or value. For rule number 1, says all non-zero numbers are significant. So what are the examples of this? Let's say we have 33.2. Since 3, 3, and 2 are not zeros, therefore 33.2 has 3 significant. Has 3. So how many significant figures do 33.2 have? It has 3. So that's basically rule number 1. All non-zero numbers are significant. So if a number is 0, by the rule number 1, it is not significant. But if the number has no 0, all of them are significant. Let's say the opposite of it is 300. So as we can see, there are 1 non-zero and 2 zeros. And thus, this 300 will only have 1 significant figure. So that's per the rule number 1. Rule number 2. Zeros between two non-zero digits are significant. So what do you mean by that? Suppose we have 2051 as our example. This 0 is in between 2 and 5, which is a non-zero digit. The 2 and 5 are non-zero digit. Therefore, this 0 became significant. And thus, this 2051 has 4 significant figures. But what if it is 2510? How many significant will then 2510 have? Since 0 is not in between any of these 3 non-zero digit, thus 2510 has only 3. Another example of this is if we have 6009. Since these two zeros are in between 6 and 9, the non-zero digits, therefore this 6009 has 4. So that's rule number 1 and rule number 2. For rule number 1, all non-zero numbers are significant. Rule number 2, zeros between two non-zero digits are significant. And so now we have this rule number 3. Leading zeros are not significant. So what if I have this number 0031? Are these two significant? No, they are leading zeros, and thus 0031 has only 2 significant figures. Another example is if I have 0.000092. How many significant figures does 0.00092 have? It has only 2. Why? Even though it has decimal point on this side, all these zeros are leading zeros and nothing but a placeholder only. And thus, these two non-zero numbers are the only significant digits. Rule number 4. Trailing zeros to the right of decimal are significant. So taking this example from rule number 3 and making it 0.0092 and then 2 zeros, this will then give 4 significant figures. This number will then have 4 significant figures. Why? As per rule number 3, these leading zeros are not. So they are not significant. But by rule number 4, trailing zeros to the right of the decimal. So here's our decimal point. And then it is to the right. To the right of that, trailing means after a number. So the only trailing zeros here is these 2 zeros. And thus, by rule number 1, these two are non-zeros, and then these two are trailing zeros, and thus 0.009200 has 4 significant figures. But this will change if I suppose say that it has a non-zero here. Let's say it has 7 here. So the significant figures on this example is no longer 4, but 1, 2, 3, 4, 5, 6, 7, 8. All of these digits will then become significant figures. Why? Because 7, 9, and 2 are non-zeros, of course. But these 3 are in between 7 and 9. And then these 2 zeros are trailing zeros to the right of the decimal, and thus all of them are significant. And now we have rule number 5. Trailing zeros in a whole number with the decimal shown are significant. Example 1.00. 1.00 has 3 as per rule number 5 because the decimal point is shown. But if it has 3, let me write it down, has 3. But if the given is like that with no decimal point shown, as per rule number 1, all non-zero numbers are significant. But this time, this 1 here, is the only number that is non-zero. And thus, these two numbers will then become not significant. And thus, this 100 has only one significant figure. Something like that, with decimal point shown, then it will become 3. There are 3 significant figures. And rule number 6, trailing zeros in a whole number with no decimal shown are not significant. If I have 100 versus 100 and a decimal point, this has only 1 and this has 3. And that's because of rule number 6. If the decimal is shown, these 3 are significant. If it is not shown, then only 1 is significant. And then, rule number 7. Exact numbers have an infinite number of significant figures. Example of this is if we have 1.0, 1.00, 1.000, it depends on how many zeros we want if it is exact, or in other words, the decimal point is shown, and then just like these examples. The last rule, rule number 8, for a number in scientific notation, n times 10 to the x, all digits comprising n are significant by the first 6 rules. So these are the rules from 1 to 6. If we have number in scientific notation, say 5.02 times 10 to the 4, automatically these 3 become significant. These 3 are significant. But then, by rule number 8, 10 and this x here are not significant. So thus, this example has only 3 significant figures. These are the rules in identifying whether a digit is significant or not. To better understand these all rules, let's try it with this example. In here, the question asks us, how many significant digits do 10.097 have? So, by rule number 1, all non-zero digits are significant. So 1, 9, and 7 are automatically significant. And then, by rule number 2, zeros in between non-zeros are significant. And thus, these 2 zeros in between 9 and 1 are significant. And thus, 10.097 have 5. So, the answer is D. For this one, which number has 3 significant figures? So, the question asks us which of these from the option A, B, C, D has the number that has only 3 significant figures. So let's try to look at A. At A, how many significant? It has only 2, 1 and 4, because 0.00 are leading zeros, thus they are not significant. And 1 and 4 are non-zeros, so 1 and 4 are significant, so it has only 2. For B, all of them are non-zeros, and so 1.4141, that 5 digits are significant, so it is not the answer. For C, 0.0 are not significant. 1414, it is, but they are already 4. And lastly, D, 0.0 are not significant, but 141 is significant. And so the correct answer for this is this D. This D. Then lastly, round off 34.2814 or 34 and 2,814 ten thousandths to 4 significant figures. 4 significant figures. So we need to have only 4 significant. So all of them, 3, 4, 2, 8, 1, 4 are significant. So let's try to look at the 4th digit. So that's, 5th digit, because we need only 4. So 3, 4, 2, 8, and then 1. Since 1 is lesser than 5, let's keep now 8 as is, because it will not get round up, rather round off. So the correct answer for this is 34.28. So that's it for this video, and I hope this was helpful, and thanks for watching.